गुड आफ्टरनून एवरीबॉडी। आज हम क्लास 12 केमिस्ट्री का चैप्टर नंबर 1 सॉल्यूशंस पढ़ने जा रहे हैं। सॉल्यूशंस में हम 3 तरह के सॉल्यूशंस इस चैप्टर में पढ़ेंगे। नंबर 1 इज सॉल्यूशन ऑफ 2 वोलेटाइल लिक्विड्स। इसमें हम राउल्ट्स लॉ के बारे में पढ़ेंगे। राउल्ट्स लॉ। Number 2 will be solution of a gas in a liquid. इसमें हम हेनरीज लॉ के बारे में पढ़ेंगे। और नंबर 3 विल बी a non-volatile solute that is a solid in a liquid. Non-volatile solute plus liquid. इसमें हमारी कोलिगेटिव प्रॉपर्टीज आएंगी। कोलिगेटिव प्रॉपर्टीज what do we mean by colligative properties? Those properties of solution which depend only on the number of particles of the solute, like your relative lowering of vapor pressure, that means when we dissolve some non-volatile solute in a liquid, its vapor pressure comes down, and that is called relative lowering of vapor pressure. And number 2 will be elevation in boiling point. Then number 3 is depression in freezing point. And number 4 will be osmotic pressure. This we will study in details in next sessions. So today we will discuss only about the vapor pressure and Raoult's law. So what is vapor pressure? अगर हम एक क्लोज्ड वेसल लेते हैं और इसके अंदर एक लिक्विड लेते हैं, सपोज प्योर लिक्विड ए, it may be water, it may be ethanol, anything. Okay, now these surface molecules, they have a tendency to evaporate and go in the vapor phase. ऐसा क्यों है? क्योंकि जो सरफेस के मॉलिक्यूल्स हैं इनके पास दो प्रॉपर्टी हैं। नंबर 1 इज दे हैव हायर काइनेटिक एनर्जी देन द बल्क मॉलिक्यूल्स। इसको हम बोलते हैं बल्क मॉलिक्यूल्स। और ये हैं सरफेस मॉलिक्यूल्स। और नंबर 2 इज दे एक्सपीरियंस लेस इंटरमोलिकुलर फोर्सेज ऑफ अट्रैक्शन। सपोज ये एक मॉलिक्यूल है तो इसके ऊपर चारों तरफ से जो है फोर्स ऑफ अट्रैक्शन लग रहा है, जबकि सरफेस मॉलिक्यूल जो हैं इनके ऊपर खाली नीचे की तरफ फोर्स ऑफ अट्रैक्शन लग रहा है। सो नेट फोर्स ऑफ अट्रैक्शन एक्टिंग ऑन द सरफेस मॉलिक्यूल्स इज लेस। दैट इज व्हाई दे हैव ए greater tendency to go in the vapor phase. So they have lower intermolecular forces of attraction. These are called van der Waals forces of attraction. Or sometimes they may have some hydrogen bonding also, if the molecule is having hydrogen bonding in that case. अब होगा क्या कि ये जो मॉलिक्यूल्स हैं ये वेपर फेज में जाएंगे तो यहाँ पे एक वेपर प्रेशर लगाएंगे और इक्विलिब्रियम कंडीशन में दिस लिक्विड और वेपर के बीच में देयर विल बी ए इक्विलिब्रियम at certain temperature, because this vapor pressure will depend on temperature. If we increase the temperature, then more vapor pressure will generate, because more molecules will try to escape to the vapor phase. So when we increase the temperature, this equilibrium will go to the right direction, means more vapors will be formed. Okay, so at equilibrium, at certain temperature, this whatever pressure is generated, that is exerted above the surface of the liquid, that is called vapor pressure. Okay, so what is vapor pressure of a liquid? It is nothing but the equilibrium pressure generated in the vapor phase at a particular temperature. अब ये वेपर प्रेशर किस किस चीज पे डिपेंड करता है? व्हाट आर द फैक्टर्स अफेक्टिंग वेपर प्रेशर? फैक्टर्स अफेक्टिंग वेपर प्रेशर. ओके, सो नंबर 1 इज नेचर ऑफ द substance or nature of liquid. Okay, say water will have different vapor pressure, methanol will have different vapor pressure. Okay, ethanol will have different vapor pressure at a given temperature. So it depends on the nature of the substance. Number 2, it will depend on temperature. If we increase the temperature, vapor pressure will increase. First, we consider the effect of nature of liquid. In that case, we classify them as more volatile and less volatile liquids. What do we mean by volatility? Volatility is nothing but the tendency to escape in the vapor phase. So if it has a higher tendency to escape to the vapor phase, means it has a higher vapor pressure at a given temperature. So more volatile liquids means they have higher vapor pressure at a given temperature. Okay, and less volatile means opposite, that is less vapor pressure at a given temperature. Examples may be, your less volatile may be water and more volatile may be ethanol. Okay, so why water is less volatile and why ethanol is more volatile? This is because of extensive hydrogen bonding in water. You know that each molecule of water is hydrogen bonded with 4 different molecules, while in case of ethanol, each molecule is hydrogen bonded by 1 molecule only. So it has more hydrogen bonding as compared to ethanol. That is why the boiling point of water is higher, say 100 degrees Celsius, and ethanol it is 78 degrees Celsius. That means ethanol is more volatile and water is less volatile. How this vapor pressure depends with temperature. Suppose I draw a curve for vapor pressure versus temperature, then the curve will be like this. Okay, suppose 3 different liquids are given to you and they exert this vapor pressure like this. This is liquid X, this is liquid Y, and this is liquid Z. Now I ask you which liquid has higher forces of attraction, higher intermolecular forces of attraction between its molecules. How will you tell? So the liquid which has lower intermolecular forces of attraction will exert higher vapor pressure, or it will have a higher tendency to go into the vapor phase. So if I draw a vertical line like this, so at a given temperature, vapor pressure of Z is lower, vapor pressure of Y is higher than this, and vapor pressure of X is highest. So what we can say is X has the highest vapor pressure. So vapor pressure of X is greater than Y is greater than Z. So if X has the highest vapor pressure, means X will have least intermolecular forces of attraction, because that is why the molecules are trying to escape to the vapor phase. They experience less forces of attraction among the molecules, and Z will have the highest value of intermolecular forces of attraction. If I ask you which has the highest boiling point, so boiling point will be in opposite. So boiling point of Z will be greater than Y, will be greater than X. Okay. So this is how the boiling points and vapor pressure are related. Suppose I give you three liquids. One is methanol, other is ethanol, and other is propanol. Which will have higher boiling point? So boiling point of propanol will be higher than methanol and will be higher than methanol. So methanol will have least boiling point, and it will be most volatile, and this will have the highest boiling point among the given three, and it will be most volatile, and this will be least volatile. Okay, so volatility is inversely proportional to the boiling point. And suppose I give you benzene, toluene, and say xylene. Okay, benzene is C6H6, toluene is C6H5CS3, and xylene is C6H4CS3 whole twice. It will be a mixture of ortho, meta, and para xylenes. So it will be also having this order of boiling point will increase in this order. Okay, benzene will have the least boiling point and xylene will have the maximum boiling point. Why this difference is occurring? Okay, this is because of the van der Waals forces. Bigger the molecule or heavier the molecule, more will be the boiling point, and lesser will be its volatility, means lesser will be the vapor pressure exerted by xylene as compared to benzene. So if hydrogen bonding is there, that will also increase the boiling point. Okay, if more extensive hydrogen bonding, then boiling point will be more. Suppose I give you C2H5OH, that is ethanol. I give you glycol, that is CH2OH, single bond CH2OH. This is called ethylene glycol. And I give you glycerol, that is CH2OH, CHOH, CH2OH. Okay. Now which will have the highest boiling point? So definitely this glycerol has the highest boiling point, and glycol is less than this, and ethanol will be least boiling point. Why this is so? This is because of the extent of hydrogen bonding. It is called monohydric alcohol, so it has less hydrogen bonding. Glycol is a dihydric alcohol. There are two OH groups, so it will have more hydrogen bonding than ethanol, and glycerol has three OH groups, so it will have the maximum hydrogen bonding. So the boiling point of glycerol will be maximum as compared to the glycerol and ethanol. Okay, so hydrogen bonding affects the boiling point to a large extent. अभी हम सॉल्यूशन ऑफ टू वोलेटाइल लिक्विड्स को लेते हैं. सॉल्यूशन ऑफ टू volatile liquids. Okay, suppose there is a liquid A in this container. Definitely it is a closed container. So this is liquid A. It will exert some vapor pressure, that is called PA naught, and there is another liquid B. This will exert the vapor pressure, say PB naught. Now if I mix the two liquids, okay, then I will have A plus B in this. And what will be the vapor pressure of the solution? That will be neither PA naught nor PB naught, nor it will be the summation of two. It will be something different. That is given by the Raoult's law. So vapor pressure of the solution of two volatile liquids is given by Raoult's law. What Raoult's law says, that if you have a solution of two liquids, then the partial vapor pressure of each, say I say PA is the partial vapor pressure of A and PB is the partial vapor pressure of B. Then PA is directly proportional to XA and PB is directly proportional to XB, where XA is the mole fraction of A in the solution and XB is the mole fraction of B in the solution. So this is the definition of Raoult's law. So what we can say the Raoult's law is, that is the partial vapor pressure of a component in a solution is directly proportional to its mole fraction in the solution or in the liquid phase. Okay, so P total will be equal to PA plus PB. As per the Dalton's law of partial pressures, the total pressure is the sum of partial pressure. So the partial pressure due to A is PA, partial pressure due to B is PB, and the total pressure is PA plus PB. And PA and PB are given by the Raoult's law. So what Raoult's law says, that partial vapor pressure of A, if I write as PA, is directly proportional to XA, or I can write PA is equal to say some constant into XA. Now to determine this constant, if I take pure A, then for pure A, PA is nothing but PA naught equal to K and XA will be equal to 1, because we are talking of pure A, and we know that XA plus XB equal to 1. In pure A, XB will be 0, so XA equal to 1, so K will be nothing but PA naught. So this equation will become PA equal to PA naught into XA. So partial vapor pressure of A is equal to vapor pressure of pure A multiplied by its mole fraction in the solution. That is the Raoult's law. Similarly, I can write that partial vapor pressure of B is equal to PB naught into XB, and the total pressure P total will be PA plus PB. That will be nothing but PA naught XA plus PB naught XB, and that is the how we determine the vapor pressure of the solution having two components A and B. That is nothing but PA naught XA plus PB naught XB. Now if I ask you what is the composition of vapor phase in the solution. So this is the solution of A and B. Okay, this is the liquid having A plus B, and this is the solution phase having mole fraction XA and XB of liquid A and B. Now we ask what is the composition of the vapor phase. So this vapor phase will have molecules of A as well as B. So if I say Ya is the mole fraction of A in the vapor phase, that will be nothing but partial pressure of A divided by total pressure. Okay, this is as per Dalton's law. And what was PA? PA was nothing but PA naught XA upon P total. So that is your Ya. And what about YB? Y will be nothing but Y1 minus Ya. Okay, that is how we can calculate the composition of the vapor phase. That is Ya and YB. Okay.